inside a typical reach-in cooler and making an assessment of whether or not they have shaded pole motors or have EC motors. The way that we tell is once we pulled back the product, pulled out the undercarriage, we find a plug, actually unplug that motor. If you watch how this motor slows down, it comes to a nice smooth stop. Alright, here's an example of a case motor behind a frozen door. There's one of these motors behind every single one of these doors. And as you can see by our visual test, unplug the wire, that motor stops smoothly, does not index when it spins slowly, and when we plug it back in, it starts instantly. So what we're looking at here is an aisle that has 2 rows of frozen door coolers. Each side has 28 doors, so a total of 58 doors. Behind each door is a shaded pole motor. So there's an opportunity to change out 56 motors just in this aisle. The aisle directly next to us is exactly the same as this. Hi, we're here in the produce cooler and we're just doing a check to see if these are shaded pole motors, which they are, and we get a really good application for EC motor installation through the evaporator. They come to a nice smooth stop and start up instantly. These are both indicators of shaded pole motors ready to be updated to EC motor technology. So what you're looking at is an evaporator full of shaded pole motors. Another great application for EC motors inside a freezer. What we've got here is a seafood cooler. It's going to be another good application for EC motors. 2 in here. Here we are in the bakery. We've got another application for EC motor swap out, 2 motors here. Here we are at the meat freezer. As you can see, another great opportunity for a 5 motor shaded pole to EC swap out. Come into the butcher shop, and we have sealing evaporators, also another good application for EC motors. You can see I've got the amp clamp hooked up to take a measurement of the original shaded pole motors, and what we're showing is just over 5.1 amps being drawn. As you can see, with the EC motors installed on high speed in the same evaporator that was reading over 5 amps with the shaded pole motors is now reading just over 1.2 amps. Another great application for EC motor swap out in 2 evaporators, a total of 8 motors in this cooler. So what we have here is a great example of an existing cooler that has a lot of opportunity to be updated with current technology. We have old halogen T12 lights to be updated with very efficient LED lights. We also have an opportunity for night curtains to be installed on the outside here to pull down and attach magnetically to the top here.
Why do I put a night curtain in? Well, there's a few reasons. Number 1 being it's going to save about 35% energy every hour that the curtain is pulled down. Southern Cal Edison's refrigeration lab did a very extensive testing on low emissivity night curtains, and what they came up with was 36% of the energy that it takes to maintain temperature in here gets saved by simply pulling down a cover. And really, in essence, what we're trying to do here is not seal the opening. This is not designed to be a sealed cabinet. What we're trying to do by pulling the night curtain down and keeping it in place at night, we're going to make sure that the air curtain that's moving up and down inside the case doesn't get disturbed and we get spill. We're paying money to refrigerate the air in here. We don't want it getting spilled out down onto the floor and into the retail area. Vice versa, we don't want warm air getting sucked in at night either. By doing so, we're going to save approximately 35% on the energy.
Alright, so what we have here is a great example of an opportunity for anti-sweat controls to be put into action. This is 2 aisles, or 1 aisle, both sides, of frozen door coolers. The anti-sweats are an internal heater that heat both the door and the frame, and keep those from icing over or condensating and producing water on the floor or water on the glass. The anti-sweat controller in a dry environment reduces your consumption by 70 to 80 or even up to 90%. But it does not allow that door to deteriorate over time because it has a maintenance cycle.
The door sensor with my finger, the yellow light should come on, and it did. The reason that the sensor is activating by my finger is it's actually picking up condensation through my skin. That's how sensitive these controllers are. We have the 2-channel technology, which is exclusive. Nobody else controls the door circuit separate from the frame circuit. And I'll tell you why that's important. 60% of your load's going to be on the doors. General rule of thumb. 40% of your energy for the anti-sweat load is going to be on the frame. Typically, your frame heaters are going to need to run somewhere around 65 to 55% of the time. Your door package, you can save 65 to 85% on the door package, which is the more amperage of the anti-sweat load. So because we control the door separate from the frame, we can capture an additional 15, 20, as much as 25, sometimes 30% additionally versus traditional anti-sweat controls.
In our assessment of the store, when we look at the frozen doors, we check to see that the anti-sweats are in working order. What we use is a volt pen. We find where the anti-sweat power goes into the door, pull the volt pen on there, you can see that it illuminates red. That indicates that there's voltage going in through the door and coming through the frames. You can see them light up. So these anti-sweats are in operating order, and it's a good indication that this is a great place to install an anti-sweat controller. Alright, so what we have here is an indication of a anti-sweat control that is a pulse system. It has no actual moisture sensors or any active sensing device to keep it on when it's needed and off when it's not. It just simply cycles on and off. The anti-sweat controller that FridgeWise uses senses actual moisture on the components and turns it on only when it's needed, with the exception of its maintenance cycle. So what we're looking at here is the dairy cooler and the reach indoors. This is not a frozen door application, so in this case we would use our anti-sweat control that's an MT, and it would simply control the doors and frames as one unit, whereas in the other frozen doors that we looked at, the LT controls the frames and the doors individually. This is a great application. We'll be able to control all these doors with one controller and maximize the energy savings for those controllers. Here we are in the next aisle over. It's another 28 doors on either side, so another total of 56 doors, and a great opportunity for anti-sweat controls again.